Hello everyone, in this video I'm going to solve problem 77 of chapter 6. The two-member structure is connected at C by a smooth pin, which is fixed to member BDE and passes through a smooth slot in member AC. Whenever we are saying smooth, that means that we don't have any friction. Determine the horizontal and vertical components of reaction at the supports. So we have three supports. We have supports at A, at D, and at E. So the first step is to draw free body diagram. Because we have two members, so we're going to have two free body diagrams. We have reaction forces at E, EX and EY, and then support D is a roller, so only has a reaction in Y direction. Then C, it can move along the slot, but it cannot move perpendicular to it. So we have FC here, and then we have our 500 pound at the end of the beam. So here distance is 3 feet, and then 2 feet. So because here we have 3, 4, 5 triangle and force FC is perpendicular to that, so we have 4, 3, 5 triangle for the dimension. So 3 and 4 are switched when FC is perpendicular to AC. So we're gonna write it here, 4, 3, 5. So the other free body diagram would be member AC. Member AC at A is pinned, so I have reaction forces in X and Y direction. FC would be the opposite, because our action and reaction. If I put these two free body diagrams together, then FC would go away as it should, because it's an internal force. And I have a reaction here. I have a moment here. According to Pythagorean theorem, this distance would be 5 feet. So if I write a moment equation about point A, then the only unknown that I have would be FC, and I can find that. And in this free body diagram, I have 1, 2, and 3 unknowns. So I can solve all the unknowns by writing my equilibrium equation. That's why I'm going to start with this free body diagram. The other free body diagram, we have 4 unknowns, so we can't solve it. We have to start with member AC. So summation of moment about point A, I'm going to assume counterclockwise to be positive. Force FC is creating a counterclockwise moment. Moment arm would be 5. The other moment that I have is a clockwise, 600. So FC would be 120 pound. Now that I have the value for FC, I can write summation of forces in X and summation of forces in Y to find AX and AY respectively. So here I have AX. For FC, I have a 4, 5 triangle. So here would be 4, 5. Or if I draw it here better, it would be 4, 3, 5. So component in X direction, I have negative FC. 4/5 will give me the X component equals 0. And I know FC is 120. Therefore, I have one unknown. AX would be 96 pound. Similar for AY. I have plus FC. 3/5 equals 0. FC again is 120 pound. Therefore, AY, I get a negative value. That means that the direction I assume is incorrect. So I use my 3 equations to find the 3 unknowns. So now that I have FC, I resolve one of the unknowns that I had in the other free body diagram. So now I only have 3 unknowns. If I write the moment equation about point E, then I can find my dy, and after finding dy, I can write summation of forces in X and Y to find the rest of the unknowns. So let's just start by writing a moment equation about point E. Moment equation about point E, counterclockwise to be positive. 500 is acting at the end of the beam, moment arm is 8. It's creating a clockwise moment about point E, so it's a negative value. Then I have my 120 or FC The horizontal component is not going to create a moment. The vertical component is going to create a moment. So 3/5, moment R would be 5. And force Fd is the only force that is creating a counterclockwise moment. Therefore, Fd or dy, let's call it dy to be consistent. Dy would be 2,180 pounds. So summation of forces in x equals 0. I have Ex. I have my force Fc. 4/5 will give me the horizontal component. Therefore, Ex would be negative 96 pounds. Summation of forces in y equals 0. I have negative 500 acting at the end. I have the vertical component of force Fc. Also, I have dy, which I found it earlier. And the only unknown would be Ey. So Ey would be negative 1,608 pounds. So using the other free body diagram, I could find 3 more unknowns. So the strategy is to draw the exploded free body diagram for each member and then identify how many unknowns you have and which free body diagram you need to begin analyzing. So for this problem, we had to start with member AC and then move on to member BDE.